Okay, so admittedly we will throw you through very different packages today. So there's, as always in Python, there are many ways to do the same thing, and there are even more ways to do very similar things. And so one thing we want to introduce you as a kind of a paradigm to do parallel computing with Python is task-based parallel computing, and luckily there is some output from Continuum Analytics, one of the prime Python development companies, which is called Dask. And Dask is quite mature task-based framework for Python, meanwhile. It's still very, very actively developed, so everything I say is a snapshot of more or less, hopefully, the current version and not the one, the penultimate one. And I think the most important thing in order to do task-based computing is that you are having some kind of lazy evaluation. So you can do that also by Python itself. If you use, for example, the futures or the async API. But that is not necessarily scalable to HPC computing. And in Dask, you have different ways to do lazy computing. You can also do eager computing, but you still have the control. What is evaluated lazily, so only when you need the result, and what is computed eagerly, as soon as you submit the command. So Dask delayed is one of the flavors within Dask, and it's the most flexible one. Because you're defining each and every individual task there on your own. So what you can build from Dask delayed tasks is a task graph, like you nowadays, for example, would also do in TensorFlow or in many other machine learning frameworks. So do we have a pointer here? Is it somewhere a pointer in there? No? I thought there was some pointing. Doesn't work either. Okay, so now I have it. So this is a Dask delayed code, which you find later in your notebook. And here I define different tasks. And these tasks are dummy tasks. So they take some time, like, for example, an input task. That would be a loading task for files, for example. Some common task, don't know, calculating some basic numbers that you need for all of the other tasks. A map item task, something which you want to apply to each of the outputs from the input, and something like a summarized task. And you see here this task graph is phrased in just 4 lines. So you do a list comprehension. So what these are your 20 input tasks. So there's an arbitrary number, of course, could be 200 or 2,000. Please not 1,000,000. So there are other better ways to deal with 1,000,000 tasks. You can deal with 1,000,000 tasks in Dask, but you wouldn't use this pattern here. You have a common task, and you have the intermediate tasks, where each of the intermediate tasks needs the output from the input task, and it needs the output from the common tasks, the common data. So each of those here are dependent on common task and on input, and the summarized task is dependent on all the outputs from the intermediates. So you can imagine if you have not 4 of these task types, but 20, and they have all different dependencies, that may get a little bit difficult to judge how this task graph really is from this. So Dask has a facility to visualize this. It uses the Graphis, so it's from dot. So and you see these small circles here are the input tasks, the 20 input tasks. Here the larger one should be the common task. And you see that here the common task has arrows going to all the map item tasks here. And the summarized task really is dependent on all these tasks here. And you get an output. What you can see here is if you would have an arbitrary number of processors, then you should be able to do all these things here more or less in parallel. And that's exactly what Dask is providing you with. So you can operate all these tasks here in parallel with this framework by calling compute. So only at this time that you call compute are these delayed tasks. So you're previously, you see here, each of these tasks has been made a delayed task just by putting it as an argument to the delayed function. And now we want a result that really needs some of the outputs from the other one. So this one is the only one where you need a time command because it will trigger all the other operations. The other things you saw in the beginning of the code, they will return immediately. They will just make a task here, but they will not execute the tasks. The tasks are executed only on calling compute here. And you should then later try to investigate here what you should really think about it. What would have been the shortest time that could come out of there, and what is the time you get, and then see whether that looks pretty close to it. And if you like, you can also try to find out, well, what is really the overhead of Dask per task, of Dask delayed for each task. So you have to modify the program in order to get rid of the function calls that are not Dask commands. So of course, very often you have quite regular patterns of tasks that you would like to deal with. Or you have similar task graphs, but you want to execute those for millions of tasks. And then, of course, the Dask delayed framework with the individual task graph that would get overloaded. So there is still some overhead also in memory that is needed in order to handle and maintain the task graph during execution. Therefore, there are some patterns that are a little bit more convenient and also more efficient. So for example, if you have something where you have such an arbitrary, let's say, task graph, but you want not to issue each task individually, but they have the same routes through these task graphs, what you can do is you can organize them in lists, in parallel lists. So Dask back is some kind like a parallel list processing. And you can choose more or less into how many pieces you cut your work in order to distribute it to the machine. If you're dealing with, let's say, I call it database style data, something where you have mixed types, then you're probably currently using pandas if you're working with Python, or many people do use pandas for this type of data in order to data wrangling. And Dask DataFrame, well, people from pandas, they will recognize this service. In pandas, that is the data structure you use most often here. Dask DataFrame behaves very, very similar to a pandas data frame, with the exception that the Dask data frame can be larger than your main memory even. Yeah, so you can do more or less arbitrary large data frames and process them. And also you have many things that work in serial in pandas that would work in parallel here. The equivalent to the NumPy array, also in Dask, is called array, and it behaves in most instances like a NumPy array, but also here this Dask array can be much larger than a NumPy array, and you can imagine this Dask array as kind of a tiled NumPy array, so that where each of the tiles is a NumPy array, and the overall data structure is a Dask array. And this is all as transparent as you need it. So if you're not interested, you don't need to work with the underlying sub data structures. It's not, Dask is not, let's say, a wrapper around NumPy or pandas, which means there's only a part of the functionality of NumPy and pandas available for the Dask data frame and for the Dask array. So that number or that fraction of functionality is increasing, but I think it's more or less done on demand. So if you don't find your favorite pandas function in Dask.DataFrame, you should perhaps complain to the Dask people and make a use case that they understand that this is really important to implement.
One question.
Yes?
Dask array, does it handle NumPy mask arrays?
Don't know. I don't know. I haven't
Olaf,
checked.
can you repeat the question, please?
Oh, yeah. So the question was whether the Dask array handles the NumPy masked arrays. I don't know. In principle, I would assume yes. For those functions they have implemented, I would assume that they also can handle the masked arrays. It's rather that it's probably a subset of the function. So, but I don't know. You can easily try. So Dask bag, as I said, is something where you can have very flexible task graphs within, but you choose typically the amount of batches that are processed from the processes. And a typical thing for Dask bag is, for example, processing lots of files. Yeah, if you do with pandas, if you do something like a read comma separated files, and you have thousands of those files, you probably want to process them in parallel as good as this is enabled by your I/O on your computer. And you can do this by just using, for example, wildcards within these file names, and they would then all get a different batch for each of the files. So if, for example, if you're interested in the lines of each of the files, so each file would get its own thread to work on, and then you have all the lines from within a file within each of the badges. So here that would be such a. Here's an example where I just use a sequence and partition it into 4 chunks. So they are called chunks in Dask, these batches. And you see, well, 3 of them you see here. The first is somewhere here and was not on the slide. And you can see that all the tasks in between that are needed are created automatically. You will see Dask has some very clever schemes in order to find out whether it really should be a shallow hierarchy or whether it should make it a little bit more hierarchical. So sometimes it inserts tasks in between in order to make this more into a deeper tree, that you don't have any point in the tree where you have lots of edges going off. Well, yeah, Dask DataFrame. So for example, the read CSV method that many people use in order to get some text data into pandas, that is something that is available in a parallel form. Pandas has, let's say, mushroomed in functionality in the last 2 years, and it's very difficult to keep up with that functionality, but actually most of the more important things are found there. So the one I'm missing, for example, are those for fixed width file reading. That one is not yet implemented. I will probably have to complain to the Dask people that they implement that. So Dask array, as I said, is the equivalent for a NumPy ND array. And also here you can choose or define the size of your chunks. So you see here I have a 5 by 15 array, and I choose that to have the respective chunks of size 5 each. So it will, of course, then create 3 of those things and work on those in parallel. By the way, the visualization, which is very handy, there is a couple of things you can visualize in Dask. One of those things you will see is a progress bar, for example. It is in a submodule called diagnostics. What I found very interesting when yesterday the question came up: how can you profile parallel programs in Python? So actually, Dask has has facilities to allow you to profile your parallel tasks, and I think that's even with graphical output. So that is something that tells you that this is something that is not from university origin. This package, this really comes from a company. So because these are typical features that industrial customers demand. For an HPC context where you have many, many nodes and you want to work really in a distributed fashion, there is I think it's a separate package in most distributions. It's called Dask Distributed. And you will see that this reminds you a little bit on the IPyParallel here. So in this case, we use a local cluster. And we can then define our workers, assign either directly by submit, we would directly assign work to our workers, but there are also the map functions that would then assign a lot of tasks to this distributed server that you're running here. The interesting thing for Dask Distributed is that it can be used as an in-place replacement for some of the other backends. For example, if you're using scikit-learn, scikit-learn can do, this is a machine learning module that is under very active development in the Python community, where you very often have things like grid search, where you look for your optimal parameters or something like that. And they use joblib, which is another, let's say, farming framework for Python under the hood. And you can replace this joblib by using Dask Distributed and get all the advantages that you have there. So the resilience, the profiling, those tools that are available in Dask, which are not available for joblib, that's something then you would get for free. And it meanwhile also works very well as a backend even for TensorFlow. and some of the other packages. Dask distributed also can work with scheduling systems. So there are lots of ways to really adapt Dask distributed for the individual HPC environment, but it's actually, we haven't yet explored this. This is a rather new addition to our course here, and we haven't yet explored this ourselves, so we are not yet fit to see what are the important parts, what are the pitfalls in order to teach that here. So there is a Dask notebook that I think we will see later, because we decided that due to the fact that we are a little bit behind time, that Jan will do a second, throw you through in a second basin of cold water, and then you will have 2 notebooks. You may choose perhaps one over the other for your personal interest, or be able to do both of them, but we have to move on a little bit faster than we did before in order to get you also to some of the things we definitely want to cover in the end of this day. Thank you very much.